Back and now we just went over surface properties like an overview. So now let's do the demonstrations. I'll build some of those example files from scratch really quickly, just so here's where you can maybe follow along in case you just want to practice. The more you do it, the more you remember and retain and begin to understand how these things actually work. So first things first, I want to make a surface from these curves. Let's say these are sectional profiles. I want to scan in between them, so I'm going to use loft. So first thing I need to do is I need to bring these curves that I've drawn in Rhino, and I need to reference them into my Grasshopper graph. So I go to Params tab, Geometry, and I can be very specific. I can say, okay, I'm going to bring in curves, so I'll go ahead and select curves. I'm going to right-click on that widget, and instead of doing one curve, I'm going to say Set Multiple Curves. I'll click, click, click. I could also just drag and select them all at once if I needed to. Okay, but now I have those curves. I can tell that they're in here. I can hold my cursor over and it says, okay, there's 3 locally defined values, 1 reference plane curve, a 2nd reference plane curve, a 3rd reference plane curve. And of course, if I select the widget and it's highlighted green, the geometry itself in Rhino also highlights green in the preview. So now let's go ahead and make a surface by loft. I'll go to the Surface tab, go to Freeform, and you'll see that there's a number of similar ways to make surfaces in Grasshopper as there are in Rhino in the native Rhino modeling environment. I'll go ahead and select loft. You can see that there's an input for curves that we want to loft into a surface. There's also some loft options. I'm just going to leave those as a default for a moment. And here we are. Here's our surface, lofted surface. So this is the surface I'm going to be doing a few things with. First of all, we're going to evaluate it at a UV parameter in order to place a point along it. Then what I'll do is we'll pull out an isoparametric subset of the surface like we did in the overview, or like how I showed in the overview. We'll go ahead and do that step by step. Then I'll also show you how to divide a surface, which is a pretty handy thing to do. Okay, so first things first, let's say I want to evaluate the surface. This is not dissimilar to how we evaluate a curve at a t parameter, right? So if I go to the curve tools and I say evaluate curve at a t parameter, right? That input is the curve to evaluate, and then the t parameter, the sort of address along that curve to place a point along, right? So with a surface, it's very similar. I go to Surface Analysis, evaluate the surface at a UV coordinate, okay? And so I'm going to go ahead and tell it, okay, I'm going to evaluate this surface that we just created, and I'm going to right-click. Similar to how we dealt with curves, I'm going to reparameterize the surface. And so what that does is that tells Grasshopper to convert whatever the minimum u and maximum u is. Go ahead and convert it to normalize it between 0 and 1. And the same with the minimum v, maximum v, 0 to 1. And so now I can quite easily use my multi-dimensions number slider. Here's the regular number slider. Multi-dimensional number slider is right here. So I can move this in 2 directions at once. Okay, right now it's set by default at 0.5, 0.5. And so, let me just zoom in here a bit. And so if I plug that into the UV, then I basically get a point right around the middle of my surface, right? At least the parametric middle. And of course, you can see that's giving us several pieces of information at once. First of all, it's giving us a point at that location that the coordinate that we gave it. It's also giving us some of the curvature properties of the surface. So the normal to the surface curvature, and then the frame or the plane that's tangential to the surface curvature at that location as well. Tangent plane. Sorry, I'm a little nasally today. Makes my voice even harder to listen to. Okay, and so that's that, right? I think you guys get a sense of what we're talking about here. But that's where I got all those widgets. There's nothing too hard here. When in doubt, if you're dealing with making surfaces or doing something with the surfaces, you probably just want to go to the Surface tab and start looking around. And of course, if you remember a particular tool, but you don't remember its location, let's say I say evaluate, I remember evaluate, I can always double click in my canvas here and just start typing in evaluate, and I'll start getting all the different ways I can evaluate geometries, including evaluate curve at a t parameter and evaluate surface at a UV coordinate, right? So, okay. So the other thing that we went over in the overview was pulling out, maybe not just placing a point, but basically setting a minimum maximum longitude and minimum maximum latitude, and then sort of plotting out those lines and seeing where they overlapped in order to create a region between a min-max in both directions, right? And so that's called isotrim. And so I'm going to go ahead and pull that out. But it looks like a larger surface with some columns and rows drawn in it, and then one of those cells highlighted, right? And so you can think about this kind of similarly to, let's say this the surface was an Excel spreadsheet with columns and rows drawn onto them. Each cell has a minimum maximum, right, in the column and minimum maximum in the row. And so what that does is it allows you to pull out one of these cells and make a surface from it, okay? And so let's take a look at, I'm going to go ahead and delete this really quickly, get this out of the way for a moment. And so we're going to give it the surface. I'm going to reparameterize the surface. And what does it want? It wants a domain. And in particular, what this is called is a two-dimensional domain. And so a domain is basically just a minimum maximum. And so if you say, I want the domain of numbers between 0.1 and 0.2, right, then it'll basically say, okay, I know a minimum of 0.1, maximum of 0.2. And so I can go to, let's see, is it math? Here we go, math tab. And there's actually a set of tools called domain. And here we can take domains that we already have, we can deconstruct them, or we can construct them from a minimum and maximum, okay? This is one domain, and it just says, okay, what's the minimum and what's the maximum, right? In fact, a number slider basically is governed by a domain, right? So we have a minimum and maximum, and then we can find any number in between those two things, okay? So, sorry, just a slight tangent there, haha. But anyway, go back to the math tab, domain. There is a construct 2D domain, okay? And basically all it wants is the minimum u, minimum v, maximum v. And so I can go ahead and plug in some number sliders for these values. And I'll just go ahead and copy and paste a couple of these. 4 of them to be precise. Okay, here we go. And of course, I'll make the U max slightly larger and the V max slightly larger. Okay. And so all this does, when I hold my cursor over it, says, okay, I have a two-dimensional domain. In the U direction, the minimum is going to be 0.25, and the maximum is going to be 0.507. And then in the V direction, the minimum is going to be 0.25, and the maximum is going to be 0.479. And those numbers are all governed just by these number sliders. Okay, I'll go ahead and pull these in. And you can see now that it's defined just a portion of this surface, right? And I can always change that. Oh, look at that. Isn't that gorgeous? Right? You know, where we're actually drawing those latitude and longitude lines, right? And so you can see that there's a V isoparm and a V isoparm, U isoparm, U isoparm, right? And where those four sort of coincide and intersect, right? The region that's defined by those, right, is now green, right? So now, thinking about some of the things that we put together, what I can do is I can give it a list of these domains, and I can start pulling out multiple subsurfaces from this, right? And so what I think you'll begin to see is that I don't just want one sort of cell in this surface, but I want like all of them. I want to break this up in specific ways. We'll do that later on. That'll be a different demonstration. But there's one more demonstration I'm going to do for the purposes of this video. And that is we're going to divide the curve, or divide the surface, okay? So here's basically the overview file, which will be, again, part of the files that you can, demonstration files you can pull off of the website. Here it is, our curves lofted into a surface. Now I'm using the divide surface widget. Now this doesn't actually divide the surface into small surfaces, but much like the divide curve, what it does is it looks at the surface and divides it up, and then populates the surface with points at each of these divisions. Okay, and so what it spits out at is a set of division points, and then normals are all the sort of properties that you'd expect from the surface curvature at each of these locations. Right, so we're plugging in the number of divisions in the U direction, number of divisions in the V direction. In this case, I have 24 and 24. Means we'll get 25 by 25 points out. The square of 25 is 625, so we have 625 points. We'll also have 625 normals. Okay, and so I basically, just so you see what these normals look like, each of these normals are perpendicular to the surface at that discrete location. I've drawn lines, at each point with each direction, each normal direction, just so you can sort of visualize what that normal direction really means. Okay. All right, and one last thing you'll notice here, I just mentioned this briefly on Monday, but what we're getting out when I pull my cursor over, you can see that it's using a different nomenclature for the sort of output, right? So you sort of see some number separated with semicolons inside some brackets, and then after each of those bracketed brackets is in parentheses n equals 25. And so what that's saying is that we have 25 tree branches in our data tree, and inside each of those branches we have 25 items. Okay. So that might seem confusing now, but that's one of the learning curves that we need to work on in Project 2, is shifting from these sort of simple lists that we've been dealing with and really talking about more sophisticated ways for the Grasshopper to organize the information underlying everything, sort of under the hood, right? Data trees are a big part of that. And once you start to understand how data trees work, you'll find that they're incredibly useful. They're your best friend. But sometimes it can be a little complicated in sort of understanding and sort of wrapping your head around what the information is actually doing. So we're going to do a lot of practice with data trees in Project 2, just to sort of immerse you in the idea of what this nomenclature means that's being shown on the screen with my cursor hovering over the points output here. Okay. All right, so really quickly, just to demonstrate, right? I'm going to the Surface tab. In Utilities, I can find the Divide Surface widget, okay? And then from there, it's just a simple input of some number sliders for the number of divisions in U and V, okay? All right, so with that said, I want to try to start applying some of these things, and what we'll do in the next video is the responsive surface. So we're going to make a grid of points. We're going to create a surface that from a grid of points, and that grid of points and that surface is going to be responsive to an attractor point. And then what I'm going to do is I'm going to find isoparms of that surface in one direction, and we're going to make, instead of just one bow truss, we're going to make lots of bow trusses at the same time. So this is a demonstration we did on Monday, but I want to take a little time to do a video and sort of go through it as thoroughly as I can. Okay, and well, I'll see you soon.